प्रेजेंट कौन
ठीक है,
करेगा?
जाओ।
अभी जेबा करिए।
हो गया,
लाइव
ठीक है।
कैसे बड़ी चीज़ है?
माइक किधर है?
ये तो फोटो इसका फोटो आ ही नहीं रहा है।
वहाँ से माइक कनेक्ट है।
अरे वो कैमरा है, वो
वॉइस के लिए क्या?
वॉइस के लिए है। हाँ आ थोड़ा उधर हटा। नहीं इसको यहाँ सेटअप करने के लिए करते हैं। आ रहा है करना पड़ेगा। ये शायद नहीं कैमरा,
यही कैमरा लैग कर रहा है यहाँ बैठ कर ना पे। ये माइक है,
ये माइक है।
ये माइक है।
ये कैमरा
लैग हो रहा था।
सब ऐसे ही बोलेंगे इसको।
बैठना पड़ेगा।
यहाँ पे ऑपरेट करना होगा।
ऑडियो चेक कैसे
तो
होगा?
ऐसे इसको अप कर दो पूरा। आ जाएगा कुछ प्लेसिंग का।
हो गया।
ये लिंक पे जाओ। लिंक किसका बना? ये क्या साइट?
ये रोबोटिक्स का
नहीं, वाइट स्टूडियो जाओ तो क्या है नाम?
इंक्यूबेशन सेंटर पे, उस पे लाइव है। उस पे एक बार जाओगे लाइव वाले पे।
आ रहा है अब शायद पीपीटी,
अब
है ना? अब आ रहा है।
आ रहा है यार।
ठीक है। इसको स्टार्ट करना पड़ेगा क्या?
नहीं वो ऑन है।
रोबोटिक्स।
Good evening, everyone. We are from Robotics Club. As you can know, that robotics is a field of engineering and technology that involves the design, construction, operation, and use of robots. Robots are programmable machines that can perform tasks autonomously or with guidance. They can range from simple systems to highly complex ones, often equipped with sensors, actuators, and sophisticated control systems. Robotics intersects with various disciplines like mechanical engineering, electrical engineering, computer science, and artificial intelligence. The goal is to create machines that can assist, augment, or replicate human actions in various fields. This STEAM field is one of the having the bright future. Now, we Robotic Club are once again back to continue session regarding Pitchtember. Now, in today's session, we're going to introduce about the TinkerCAD.
Hello, my name is Deepak. I am from Electrical Department and Robotics Club Technical Team Member. I am representing the Pitchtember Session 2 of Robotics Club. That is introduce TinkerCAD. What is TinkerCAD? Means it is a software. In a computer, you can design or create or simulate a circuit in which you can perform many functions from circuit. Simulate a real-time functioning. What is CAD? CAD is computer aided designing, means how to create circuit and design a circuit in real way. How to visit in browser to open this software. This is www.tinkercad.com and create a student account. New student account. Now click on new button and select circuit on 2D way. Create a new blank page and now select many functions. But we are working on a many components like Arduino Uno, LED, digital pins. Using digital pins to send input and output informations using wires with different colors in online platform. Now we can use many components like servo motors and LEDs and potentiometers, resistors, diode, and many other circuit boards we are using on online TinkerCAD software. Now there are two parts. One the designing part and second is coding and blocks part. In code you can give a task to perform circuit to different modes. This is a code part. First is void setup. Void setup is means the code runs only once when the simulator is on, in which you can explain pin mode. Pin mode is you can define pin. You can give input or output in once. In second, in brackets 13 and output. 13 comma output. 13 means you give output signal from 13 pin from Arduino board. And then you can also give input from few pins. These are 6 PWM pins. You can write input in which they give input signal from pin mode. Next, the void loop in coding part. Void loop, the code runs many times in which you can simulate their circuit in which digital write means you can read your power with digital like in which you 0 1 high or low. 0 means low and 1 means high in 13 pin. Delay means delay you can wait for a 1 seconds. 1000 millisecond means 1 seconds. You can मीन्स तुम जितनी देर डिले रखोगे उतनी देर तक हमारा कोड वेट करेगा, उतनी देर वो रन करेगा वो चीज़ डिजिटल राइट. ओके, you can increase the delay in 2000 3000 2500. You can wait for that second and then digital write. Okay, now what we are working on Arduino Uno, LED, breadboard, 20 resistors, potentiometer and servo motors and some another extra components in a TinkerCAD software. Then to the code. Now switch to Zeba for explaining code of using potentiometers, LED and resistors.
Now, as you know that the Arduino UDE programming system leans on C++ language. C++ is a case-sensitive language. Now there are various codes that we can add to program the Arduino IDE. So first we're going to program in the TinkerCAD. Now let's start by entering the account. First we go to login page, and then as you can see I already have an account. So we're going to add a new design. So in this is our workspace in which whatever elements we want we can enter. Now to search what component do we want, we go to this side. As you can see, there is components which has in various options like basic, all, and etc. But we're going to do basic as if we are in beginners. Now first add this. As you can see, we got a duplicate version, virtual version of the Arduino Uno. These are the digital pins from 0 to 13. As you can see, there is a total number of 14 digital pins. Here it is the analog pin. Analog pin we have from A0 to A5, total of 6 pins. These are the blocks in which we could add our codes and commands. And as you can see, in these blocks, whatever we add, it's going to be added over here. As you can see, this is the default code which we're going to run and to see what happens. So when we start simulating, we would see that this L is blinking. This is the built-in LED. That means that in reality, if we follow these codes, then we will see that there would be a blink in this LEDs. Now we're going to stop and start to actually with an example of lighting or blinking an LED. As you can see, we find there is resistor. The resistor's value can be varied by simply typing the number which you required, such as 18 kilo ohms. See, the color is also changing in this resistor. We can also have these options from mega ohms and giga ohms to pico ohms range. We could also change the colors of these LEDs. Now what we're going to do is we're going to ground the cathode. And make some changes in the codes. So this is the changes we have done. As you can see, the code is also changed over here. Instead of the built-in LED, it is changed into 13 pin. So when we start stimulating, you can see there's an error. See, in here there is some error as it's getting exploded. Now in TinkerCAD we can also see why this error is happening. Let's just stop simulating. And we comment out these and start stimulating. See, in this, the TinkerCAD also shows that why error is happening, so that we could modify by adding this resistor. As you can see, now it is working without any errors. Now moving on to the next example, that is why we use potentiometer. Now here you can see this is a potentiometer. It has 3 terminals, terminal 1 and terminal 2, and a wiper. This terminal 1 we are going to connect to the ground. This terminal 2 we are going to connect to the power. And this terminal 3 we're going to connect to the analog pin. Now we're going to create a variable. In this one, we're going to vary the time in which the LED will blink. As you can see, this when we when we are stimulating, we can actually change this pin to shorten or lengthen the time duration in which the LED blinks. Now in these code we have made changes, such as we have declared a variable first. When we variables, we can type any variables which we want, such as here I have want to write it as sensor. Now this sensor is a variable in which we is the name of the memory location in which we are going to tell. Now we're going to set the sensor to read the analog pin. As you can see, sensor equals to analog read A O. So in this one, what we did is that the terminal or the wiper terminal or the middle terminal of the potentiometer is connected to the A naught. That's why we have declared sensor to be equal to analog read A naught. So what we did is that this sensor is also in this delay function. Now, as we know that the delay function is delays the delays the other statement or other command by whichever millisecond we want. So in this delay, we have put in sensor. That would mean that if whatever is the value we set in the potentiometer is going to delay by that second. So in this, we could manually change the time duration of the LEDs. Now we're going to get one more example for better understanding. This is a breadboard in which we have these pins connected. As you can see, this is connected horizontally, whereas this one is connected vertically. In real life also, the breadboard is connected like this. This is a smaller version of the breadboard. That's why it is like this. For a larger version of a breadboard, we have this. In this, as you can see, there are different types of breadboards found in LED. Or this. Now we're going to blink 3 LEDs in a fixed pattern. We're getting an Arduino and 3 LEDs. And of course, resistors. First, we're going to connect all these. So for neat and clean circuit, we are going to operate this in the breadboard. Now we're connecting the resistors in the respective terminals. Now we're connecting this terminal to the positive one. And we're going to the positive terminal. Sorry. We're going to the negative terminal to the ground. Now we connect this terminal to a pin, such as the 13 pin. And we mark it as red. Now this one we're going to connect in the 12th pin. And we will mark it as yellow. Now we're going to connect this pin to the 11th pin. And as such. Now we're going to code for these. Or we could change the color also for differentiating. Now let's go for coding. Let's delete this block. And let's get started. First, we're going to drag and drop these blocks. And we're going to duplicate this 3 times. Now for easy understanding, we're going to also see what is happening in the programming section also. Now we select the pins which we are going. Now we done the coding and now let's start simulating. There's some problem over here. Yes. Okay. नहीं work कर रहा है। अच्छा ये क्यों ये बड़ा
बल्ब को फ्लिप कर दो।
अरे नहीं ना होगा सही है
एनोड को नेगेटिव कर दिया। रजिस्टर को नेगेटिव में डालना।
हाँ क्या तो उल्टा है
जस्ट फ्लिप कर दो।
उल्टा नहीं हो पाएगा
इसको ये जो उसको
ये बता हाँ हो गया
ठीक है।
Look at this, make it neater. As you can see, the LEDs are blinking in a certain pattern, and like this we can make multiple LEDs blink.
Hello. Now Zeba is creating a circuit, and now I am changing a code to simulate different types of functioning of LEDs. First of all, I can see the circuit, how to read a code with real time. First, the void setup and the code runs in one time. They fix the pin configurations in the points in point Arduino in 11, 12 and 13. They gives output. Output means they gives power from Arduino board 11 from 11, 12 and 13. Second function is void loop, in which the loop means the function runs many times in the functioning. When the circuit is on, the code is run many times. First line is the digital write 13 comma high colon means the digital means the pin reads many values high, low and medium types. In 13 means the 13 gives input from Arduino in which they high. Or the second line is delay means they wait for 1000 milliseconds. Now you can change the delay, then you can see the working of the circuit in real time. First of all, you can stop the simulation and then working on a code part. You can remove delay and change their configurations to see the different change. Now you can remove the delay from all of LEDs. They can all of us run with exact all in one time. Also you can remove the low part. Now you can give a delay. Of 500. That means your LED is glow for a 0.5 milliseconds. Also you can remove delay for a 13 pin. Now simulate the circuit. They gives a error. Function undefined reference to delay. Function Now you can see the change in LEDs. Now you can give a delay of 2000. First of all, you can stop the simulation and changes its delay time. You can see your LED is burned for a glow for that time. You can give in delay. First 2000 seconds, that means they wait for 2 seconds. Now you can see the change in circuit. The LED is glowing for 2 seconds. 2000 millisecond means 2 seconds. And you can also changes its low. When you remove low, they only have high. Now I am removing the digital right 12 high, 12 low. That means you can off the LED, you can remove the code. Your LED is already in glowing portion. And now also you can remove commented that code. Also they can work. In code there are only high portion. That means your LED is only in high. That means they always in on. They always functioning in on. Now I am moving to PPT. Now this is the code part. Now I am reading from first the hashtag define LED pin 11 means your LED pin is fixed in 11 point on a Arduino board. In define means you can fix the pin points. Now second you can fix the pin of potentiometer to Arduino. Then define potentiometer pin. Void setup means your code is run in one time in functioning mode. Now pin mode, LED pin. I am explaining in previous example. Void loop. In potentiometer you can declaring a variable. You can store a value of potentiometer value. ये analog read means they can read analog value from 0 to 255. That means analog means they can read mine in practical way from negative to positive. They can read from sensors also. Analog read potentiometer underscore pin means the value of analog is save in the value of potentiometer value. Now you can control the brightness of a LED using int declaring a variable brightness int data types int brightness is equal to potentiometer value divided by 4. You can divide the value of analog read value with 4. Now you can read to analog write. Analog write means your LED take a value in analog write mode.
डिवाइस ऑफ हो जाए ओबीसी स्टूडियो को तो इन जो स्लाइड्स में कैप्शन नहीं होता है
Okay.
ऑप्शन है ना ओके का वहाँ
Okay. Analog write means you can write the value from LED. They can glow. Next, I am explaining that part. Now in Arduino board, there were a value from analog read from 0 to 255 will be converted into voltage from 0 to 5 volt. 255 means 5 volt and 0 means 0 volt. In coding of Arduino, you can also use digital write, in which they can same as analog write. Analog means analog value take, and the digital write means they can give values in form of 0 1. Similarly as a square waveform.
प्रोजेक्ट को डिस्कस करते हैं क्या
Now you can I can give a homework for you. You can create a file in your mail in TinkerCAD software. The homework is LED traffic light. You can take a 3 LEDs. You can take a breadboard and wire in proper way to create a circuit and functioning of a LEDs. You can take delay of different seconds. You can to manipulate the working of LED system in proper way.
Yeah, good afternoon. So, Still Jeva and Deepak has explained about the 2D designing, that is the circuit designing in TinkerCAD. Now I am going to the second aspect of TinkerCAD, that is the 3D designing, and TinkerCAD is widely used for the 3D designing. So let us go to the 2D design, 3D designing in the TinkerCAD. So on this, I am going at the TinkerCAD. Yeah. So let me go to back. Now click at the create option and go to 3D designing. It's loading. Now at the 3D designing we have mainly three interface. The first interface is the workspace. Second interface is the component, and third, the upper one interface is for the function tool. Now I am going to explain creating a small shape in 3D. So for this we have various options to select. For example, this is a cube, this is cylindrical structure, this is circular, spherical, and this is like a prism structure, this is cone structure, and we can also add the text. So we can also search the basic structure from here. For example, I am going to design a 3D table. So for this I am going to add a basic shapes. For this I am selecting a cube and just I have to put this, and now we have to set its dimension. For example, I am extending here at 70 and width is 74, and now we can adjust the height from here. I am adjusting the height to 2. Now we can also set its altitude. So just click on the shape and go whatever altitude we want. So I am going at 30. So now we can see our shape at the different angle. For example, this is the top and this is the front, this is left, this is back, and this is right. Now I am going to add leg of this table. So I am looking at so for adding the leg I am selecting a cylindrical shape. Just drag this shape, and take a proper view so that we can set this leg properly. So I am setting the dimension of this leg. So initially the dimension of this cylindrical its height is 23. Now we have to set its height to 30. Yeah, okay, it's 30. Now I am changing a dimension of to nearly 5 and 4 and 7. No, 4 and 3. Now it's okay. I am looking at different angle, so it is better. So just adjust its leg. Now I am taking its bottom view. It seems that there is some alter, so we need to fix this. So I am shifting the leg little bit left. I think now it's okay. Yeah, I need to shift it little bit left more. And there is something. No, I have to delete this. This is the unwanted person, so I have to delete this. I don't have to add any note, so just delete this. So I am adjusting its leg, so I am shifting a little bit left, and now I am taking its bottom view. So now it's okay. Now we need 3 more legs, so just copy this leg. For this I am using Ctrl C and Ctrl V. So I have get its copy. So just adjust its leg. I am again taking the bottom view to see the proper configuration of the leg. Now we need to shift it little bit right. I think it's okay now. I am taking yeah, the 2 legs are now in a proper configuration. Now we have to sit for the 3rd and 4th leg. Now again we are copy the link. For which I am using Control C and Control V, and now I am setting the configuration of this. I think it's okay. Again I am taking the bottom view to see the proper configuration. Yeah, this all these three legs are in the proper configuration. Now I am setting the last leg. For this again I am copying this leg and paste. Yeah, our fourth leg is almost ready. Now yeah, this table is almost ready. So in this way we can design our 3D model. Along with this, basically in the robotics we need to design before designing a bot, we need to design the bot. So here we can design our bots. We have different options as I have described earlier. So we are on the conclusion part, and now the Jeva will explain the conclusion of this.
In conclusion, Arduino has played a significant role in the democratization of robotics, making it more accessible and affordable for hobbyists, educators, and aspiring robotists. It is user-friendly programming environment, and a wide range of compatible sensors and actuators have empowered individuals to build and program their own robots without extensive technical expertise. In this conclusion, the TinkerCAD is a computer aided design software in which we can design and simulate any circuit. The freeware allows for file editing, which enables you to create existing designs. You and your designers can also upload and alter old 2D and 3D plans. With TinkerCAD, you can make new models using the software's modifiable shapes and objects. TinkerCAD then gives you the freedom to combine shapes, add movements, and stack blocks. With these actions, you can create a 3D design that is essential in prototypes. You can also develop circuits using TinkerCAD lines and customizable shapes. The code blocks that then helps you in devising marketing campaigns through GIFs. Lastly, TinkerCAD offers design presets to help you get started in the software. Thank you.